attention to yourself with questions. Again, feel free to drop messages in the chat in either Discord or the Zoom session, preferably in Discord, but totally understand it. All right. So I went through and I looked through my basically the practice exam and exam I gave out last time classes were in person, which was a while ago. So I will be sharing some either this document or a document I have more accurately modified to make sure there's the content is appropriate. I'll be sharing that tonight. If we get to Tuesday and people are still having difficulties with that, then I will push the exam back to, to week 6 Tuesday. Okay. But at the end of the day, I want to make sure that what I'm testing is something that everybody is able to prepare for. Our testing schedule as a result will most likely look like week 5 or 6, week 10, and then and probably like week 14, close enough to the end of the class. So, let's see. Or perhaps I give out, more tests at lower stakes, but we'll see. Again, I am transitioning my class, and unfortunately, the truth of the matter is that no matter what class you're taking, if your professor cares about the class, it's always an experiment to see, okay, what will go better, what's going to go worse, right? There's some classes where that's not true. Like in 2168, I am very comfortable with where 2168 is. So speaking of 2168, I wanted to mention this before I completely forget, because I should mention this. So you may or may not be aware, Temple has satellite campuses. We have a satellite campus in Rome. We have a satellite campus in Tokyo. In summer of next year, it's not been confirmed yet, but I am planning to teach 2168 in summer of 2023 at Temple, Japan. So which would, if you take this class and the next class, would line you up to take that. I figured I'd throw that out there because there are probably some people in this class who like Japan. That seems to be a above average kind of thing in computer science. Yes, question. Sorry? I believe it's more like 8 weeks. Yeah, I believe it's 8 weeks. They do their summers a bit differently. It would be, last time I taught there, which was in 2018, I taught Tuesday, Thursday, and the classes were, and it was just a 3-hour block each, on Tuesday and a 3-hour block on Thursday. But the way that I arranged the courses for 2168 is that the vast majority of your time in class is spent working on those homeworks. Essentially, those 3-hour blocks would be labs. And then the lectures are all pre-recorded stuff. So, whereas Theor, it's more of a hybrid kind of deal. Where I try to do as much flipped as possible, but we do a lot of review in class and a lot of exercises. Okay. So I figure I mentioned that. I will let you know as I confirm more things, but regardless, the chance to study abroad is pretty good. And I don't know how it works for Temple, but I know when I was doing my undergraduate at Georgia Tech, that for students who were out of state, it actually made sense financially to study abroad as much as possible, because you then paid in-state tuition instead of out-of-state tuition, which for a weird reason. So if you're paying out-of-state tuition, and that's significantly different than in-state tuition, it might be worth looking at about how that works, right? So I have no idea if that's the case here. But it's just a thought. Now, going back to our content, let me go ahead and continue pulling up my file. So here, so I have two GitHub repositories, one of which is Classroom, which is public, and then I have my private GitHub repository, which is teaching, and that's private. So I have an exam one practice PDF right here. And again, I will probably be modifying these. And I've generated way more questions than you would expect to do on the exam, because these were more questions than were needed for a 2-hour exam. And the exam we're planning on doing is 50 minutes. So way more questions than you would need. So a couple things you can expect on the exam, and I do plan on reviewing this whatever on the day before the exam, whatever that day is. True or false? Computer science is the study of computers. So we will go over basic histories and concepts. So just a kind of hint here, your first lab and whatever you decided to do for it might be useful to know. Okay. You will expect maybe a couple of small point questions like this, like a couple of, hey, here are order of operations. Do you remember how order of operations work in Python? Oh, by the way, especially, do you remember how modulo works? Do you remember how this works? Because I'm not going to let you use a calculator. You should be able to solve this problem without a calculator. Looks scary, right? But what is it? It's 0, because when you're doing integer division, any big number, any big number divided by an even bigger number becomes 0. When 168 be offered in Rome or Tokyo? Tokyo. I've been actively trying to do, improving our offerings at Temple Japan. So a couple of things where I'll give you some code and do some operations and ask you what the value is. So these are the kind of questions I'm able to ask when you don't have a computer that you can evaluate. Again, I will send this out or a modified version of these. Probably not these. Yeah, these were me being silly, a lot of these. So I'll tell you what I did last time I gave these questions. I made all the answers true on the exam. So that should give you an idea of the kind of professor I am. Efficient, very easy to grade when I do that. Some of these I did have functions in them, but here are this kind of question over here. These are the bulk of the questions I want our exams to focus on. Okay, which do use some function calls, but the kind of function calls we'll see in lab 4. I might remove the function calls, but here, basically, given this program, draw what the turtle is going to draw. This is the kind of question you should be able to expect. Notice the kind of the angles that I'll be giving you. They're generally going to be on 45-degree angles or 90-degree angles. In other words, I'm not expecting you to need a straight edge. Yes. Is this on Canvas? It might be under files. I don't remember if files is public. Regardless, I'm going to be sending out an announcement tonight when I go through this and trim stuff that I don't think you need, and possibly add some questions that I think are relevant. Okay. Then here, suppose I change this code, and how does this basically? Here's the same code. Now I've changed it. What did changing it do? Right. So again, here I'm using the stamp command, which is one that you should be familiar with doing the turtle clock in lab 3. And I say you can draw a dot to represent a stamp, because making you draw turtles, it would probably get very boring very quickly. But yeah, create a function to do this kind of stuff. So I did like to use functions. And then here, this one was a good one. Using the draw square function, write a turtle program that will draw the shape below. Right? You can create more functions if you wish. But basically, okay, you've created this command, now use it to draw something that looks like this. So a lot of what we'll be able to check on this exam will be drawing. Now remember, the way this exam is going to work is because this is experimental time. I'm trying to do the full exam. Your first exam will be 50 minutes. And then we'll use the remaining time in the class to do the group exam where you get the chance, where basically you will pair up with, well, quad up with 3 other people to do the exam a second time. Right? Same exam. That's the plan. Going to give you the same exam twice. Once as a group, once a solo, once as a group. This gives you the opportunity to learn from your mistakes and to immediately correct your mistakes and get credit for correcting your mistakes. The weighting I'm either planning on a 60-40 or 70-30 weighting because those make, and I'm gearing towards the 60-40 for the first one because that makes the stakes low because again, this could be a complete and total disaster where I grossly underestimate the amount of time that the exam takes, right? And then it's always possible for those kind of things where I do that. Now, that being said, if you have a DRS consideration, please let me know. And here, I've included extra practice things. So things that I explicitly said, hey, we don't have enough time on the exam to do all these questions, but here's a question that I might ask in an alternate universe, right, of this exam. And that's what these practice questions are. I generally make more questions than I need for an exam, and I just keep what I need, and then I hand the rest to the students. So you have an accurate representation of the topics and the kind of questions you're going to get. Okay. This one's pretty good. And then, yeah. So some of these with the functions, again, I don't think we got the functions in time for this. So I'll probably be working more again on stuff that is lab 3 with maybe a bit of, calling the turtle to do that, but we'll see, again, I'll see where that is. So with that, I want to open up Runestone for a second. So let's actually, but again, I'm going to send that out later. So let's go ahead and open up Runestone, fall 2022. And I'm going to go into my instructions over here. And I'm going to modify. So what I did the previous years is I did these exams online because COVID was still kind of completely eviscerating people's attendance with this class. So I could not, give people exams in a proctored setting without having to, without having to make multiple exceptions and multiple things. So I did a lot of at-home quizzes that had a lot of auto grading things, and it worked, but also was a mess at the same time. But that means I do have some good assignments that are ready. So let's go ahead and do assignments. And I will go ahead and quiz 2. Let's see. Visible to students, show us timed assessment, no. And let's go ahead and change the problem to 1. This will be 1, 1. We're going to change these points values to 1 point apiece. All right. And we are going to change this, let's see, from quiz 2 to rename exam 1 practice. Rename, save. All right, so you should, and saving over here. 45-minute time expected. There we go. In other words, I expect this to be done in less than 45 minutes. But let's go ahead and take a look at these. So now you can access these questions on over here, right? So we can click on this and take a look. All right. So there we go. Compute and print the following for loop, which is compute and print the following using a for loop. The summation of 50 up to and including 100, right? The sum of all numbers from 50 to 100 inclusive, right? And if you're unable to see that, and I wrote it out, if you can't see the math equation because sometimes there are sometimes the web browsers just don't cooperate, or the server doesn't cooperate and doesn't generate the math text, right? So this one, so again, this is all this is. Sum of all numbers from 0 to 100 inclusive. Now, we can, let me just make sure. Okay, yep. So I also wrote a bunch of tests for this, or actually I used some, no, somebody else wrote these tests for this one specifically because this one's in the textbook. But let's take a look at this. So I'm telling you to use a for loop to compute numbers, right? And when we're dealing with numbers, that means we're going to use, what are we going to iterate over? What's the word? It starts with R. We're going to iterate over a range. Yes. So for, and we can do num in range. And so we want, so this is going to be the accumulator pattern. When we do summations, it's almost always the accumulator pattern. So what is the range of values we are doing? It is from 50 to 100 inclusive. All right. So our starting point is fairly straightforward. But our end point, right? Right? The for loop goes from the start, includes the start, but does not include the stop. Now, this kind of mistake on an exam will cost you like a point, like a literal 1 point out of 100, because it's a minor thing. It's an off by 1. I'm going to ding you for it so that you remember, but it's not necessarily the thing I am trying to test. I'm trying to test, can you use a for loop? Make sense? And then can you use the accumulator function? So here I would, give you points for just writing the for loop, even if you couldn't write the accumulator function, because I want to see what you know. Part of that would be, do you know how to write a for loop? So the next thing we need to do is do the accumulator pattern. So total. Now, the reason I don't put sum in, even though that would make total sense, is because it's very hard to see here, but sum is the exact same color as range. Yes. Yes, 101. See? It's an easy enough thing to make. I was talking about it being inclusive versus exclusive. So this is 50 up to, but not including 50 up to, but not including 101. So this range of 50 to 100. Meant to do that, but I got so totally distracted by talking about not naming the sum. So this is hard to see. So excellent question on Zoom. The question is, should it be 49 to 101? And the answer is that ranges in Java and pretty much all computer programming are, we put the starting point, we have the start point, we have the stop point, and the numeric range given in algebraic notation is as follows. Include the start point, exclude the end point. And the reason we do that, and a big reason we do this, is that we can tell you exactly how, is that we can use subtraction to tell you how many numbers are being added, right? This adds 51 numbers together. Because when we include 50 and 100, we have, it's not just 51 to 100, that would be, 50 numbers, or 50 to 40 to 99 would be 50 numbers. So, it's because we've got to include the 0 on both ends. So this is 50 to 100. Sorry, this is 50 to 101, not including the 101. So we don't call it sum because sum is actually a built-in function in Python. It's actually very useful if you give sum a list of numbers like this, L is a list of numbers 1, 2, 3, 98, 52, 34, and 7. And I did sum of L and I printed that out, it would actually give me an answer. It does a lot of hard work for me, and it would print out the sum of those numbers. So the reason I don't call my variable when I'm doing accumulation sum is because I don't want to accidentally make it so I can't call the sum function anymore. Python lets you overwrite some function names to use as variables because Python lets you do that kind of things because it's a very loose language. So that's why I use total. Total is equal to 0, right? And we start at 0 because we need to be able to add numbers to it, and 0 is the identity for addition, meaning that anything that we add to 0 becomes itself. So we do total is equal to total plus the number. Print, assuming it can spell print, which apparently is a challenge today. And again, checks to make sure that I've got the value, I'm not hard coding it, and that there's a for statement in this. Now, on paper, believe it or not, this takes less time to write than on a computer, because on a computer, you get all these compilation errors or syntax errors. Like, for instance, you forget to put in a colon, very common mistake when you're first starting out. Or you drop a comma, or you capitalize it here. You capitalize a variable here, but you don't capitalize it here. Very common mistakes to make when you're doing programming, especially when you just start out. Paper doesn't care because paper isn't running yet. Very obvious. And for mistakes like that, I'll ding you, depending on the severity, I'll ding you a point, half a point, or a tenth of a point, depending on how severe the error is. It's not something like if you make a mistake and that would prevent your code from running. If it's not like a mistake that shows that you don't understand stuff, I'm not gonna really give a big deal. I have to give some mistake though to draw your attention to it. Yes. Sorry? Why did I put total is equal to total plus number? Oh, line 1, total is equal to 0. So I had to define the total variable, right, in order to use it. I couldn't just simply declare it here because otherwise we wouldn't have a starting value for it. And the reason we start from 0 is so that I can add 50 to it and start at 50. Then I can add 51 to go to 101, then add 52 to that to go to 153. So I start at 0 because that's essentially a blank slate to add stuff to. And so when you're doing accumulation, be it adding stuff to a list, adding stuff to a string, adding stuff to a number, then you always want to start from a blank slate. You can definitely expect to have to write some kind of accumulation function, on the exam. Not function or code. Something like this is definitely what that exists outside of a function. Yeah, that's fine. I'm going to try to avoid functions where I can for the first, or you writing functions for the first exam if possible. Okay. Now let's go ahead and I think I'll give you time to work on the next one. So this is from the second best selling game of all time, which is different than the best selling franchise of all time. But so the second best selling game of all time, of course, is Tetris. The first best selling game, top best selling game, of course, is what? Sorry? Minecraft. Minecraft was popular. Very, very popular. So, although I think Pokemon might be the largest best-selling franchise, multimedia-wise, because that includes stuff other than the video game. All right, so this is the El Tetrimo from Tetris, one of the possible 7 blocks that you can that you can use. And here, this is another one of my kind of favorite things to do, which is called a Parsons puzzle. I don't know why it's called that, but it is what it's called. And the idea here is that you take your code, it's all scrambled up, and you drag it over here. So this one does require you to write a function. So let me give you some hints to start it. First step is probably you want to import turtle. And then what we do is that we have two functions, one that draws the whole entire thing, and then we have a second to create a square. And I say first do this, the setup, second create the square. So I tell you what the first two lines are going to be, in other words. So you write what you need to do to create a square, and then you complete what you need to do to use that function to create a El Tetrimo. And then at the very end, we call it. Now, this should be the last line. Draw El Tetrimo. So I'm going to give you some time to work on this one, and then I will go over it with you because I think that's valuable. Okay. So again, this is, if you can't find it, click on the little person over here. Go to assignments and go and hit exam 1 practice. Each of these is worth a point, not really all that much. But these were actual questions that I gave on graded exams / quizzes last semester. So that's a very good indication of the kinds of questions I like to ask. Again, comments tell you the first thing and the second thing. And also worth noting, notice that you can indent these. So the indentation matters. I'm going to share, projector mute for a second. I want to actually fact check myself. Sorry? That you could run sections of code. Right, behind the five, you had a, you know, you had a item. Yeah, the version on page. Yeah, that one I believe is a command that I believe is purple. Yeah, it's literally itself. And then I always like to start with basically the total that keeps like that runs it down to using that on and for instance, like yes, I just want to write on this for everybody. All right. So let's take a look at this question. All right, so resume share. Unmute the projector. Okay, but I was wrong. Time to fact check myself because I am definitely one for accuracy. Minecraft is indeed the best-selling game of all time, but Tetris is no longer second place. It is now third place, having been displaced by Grand Theft Auto. And poor Mario, he only takes sixth place, but he also takes seventh place as well. So you know, because apparently Super Mario and Super Mario Kart are different franchises, I guess. I don't know. I feel like it's quibbling, but whatever. But I was right about the highest grossing media. It is indeed Pokemon, followed by Hello Kitty. Like, seriously, it's surprisingly surprising what is worth. It is surprising what the relative values of different media franchises are. Pokemon is huge, and it's got and it's also had enough time to really, you know, acquire that. I mean, I literally started playing Pokemon in elementary school. God, I'm old. Okay, so now going back to this problem. So over here, right, the first thing we need to do is we got these blocks. This is what I gave to you, and I told you what to do in the comments for this, which goes first, which goes second. Okay. So let's figure out the command to draw square. To draw square, I need to draw 4 lines, right? And if I go through these, okay, here's something that repeats 4 times. And this says draw forward a side length, a certain amount for a side, which seems relevant to a to a square. So it draws forward. So you go forward and then you turn right 90 degrees. You do that 4 times, you get a square. So pretty good. So this is a fairly good, you know, way to figure that out, or a pretty good guess to start with, which is that we do draw square. This runs 4 times, and all it does is says, Bob, move, turtle, Bob, that's the turtle's name, move forward that side amount that I specified, and then turn right, do that 4 times. So if we draw that out, right, it's going to be what, if this is length side, 1, turn right, 2, turn right, 3, turn right, 4, turn right, right? You know, now imagine that I can actually draw well and it's a square. And most importantly, he ends up facing the same way that he started. Okay. So now the next step is to draw El Tetrimo. Now, the way I look at this, because I'm the person who wrote the question, so it may not be as obvious to you because, you know, I wrote it, so obviously I know the answer. But anyway, this is made up of 4 squares, and I've got a draw square function. So and I see that we've got a draw square over here and 2 draw squares over here, right? This draws 1 square, this draws another square, this draws another square, right? So I want to draw 4 squares total. And we also have a for loop over here. So let's just think about what would happen if I combine this for loop with this, you know, this single call of draw square. Well, if I had this for loop, it ran this twice, and then I ran this once, I'd get a total of 4 squares, which is the amount I need. But let's go ahead and actually, you know, think our way through it. So if I run this twice, then I'd tell Bob to draw a square, 1, 2, 3, 4, face this way, right? So this is one of the other things I try to do to make the exam and any kind of operations non-painful, which is I always try to start I always try to end exactly where I started when I do some kind of geometric shape and facing the same way that I started, because otherwise the mental load is just simply asking for a careless mistake on a high stress situation, right? So 1, 2, 3, 4, turn right, which would be going this way now because I was facing to the left, sorry, to the right. So turn right. So if I'm facing right, sorry, if I'm facing east and I turn right 90 degrees, I'm facing south now. It says go forward 50 pixels. So that brings him over to here. Then I tell Bob to left turn 90 degrees, which turns him this way. And then if I run this again, he overwrites his previous line, goes down, down, and I've drawn 2 squares like that. And then I tell him to go right turn, go down, and then left turn. So now after running this twice, I'll be over here. Now let's see what happens if I run this. It says draw square. Well, let's do this separately because it is currently separated. If I run this code, it says I'm going to draw a square. Be here, and then I'm going to move forward, and then I'm going to draw a square. And then I disappear. Bob throws a smoke bomb and escapes. So, you know. And if we just kind of like, you know, Lego them together, we get ourselves at El Tetrimo. If we visually put them together, you know, that's what I'm going for. So over here, that means that I can take the for loop, put it over here, and we want to run this twice. That generates the top 2 over here. And then this will generate outside of the, and so this was the tricky portion. We put this outside of the loop to generate the 2 squares. If we put this inside the loop, we'll get something that looks more, more 1, 2, 3, 4, 5, 6. That's what would happen if we put it inside that. Now, the assumption when I give this exam out was, of course, you were on a computer, so you had access to the computer to actually test stuff if you needed to. But so on the paper exam, I will take into consideration you can't actually test everything. So we do that, and now the last thing we need to do is that we call this command telling Bob to draw the El Tetrimo. All right, so the next one is arrange the code so that the shape is shown in the linked image below. So also, it was a great question that got asked about earlier, which was about like, where do you start with these? For these, I should have told you, especially if you're doing them on paper, I'll tell you where the starting point is. But for this one, you're starting in the center. You're starting in the center. And you're making this kind of snowflakey symbol, right? So this one, again, this one is dealing, as you can see, with 45-degree angles. There are no functions in this one, right? So this is definitely even a better recommendation. This is actually one I have done on the test and has been on a paper test before. So, and I will most likely have to remove now because it was on a paper test. And now I have, but that's okay. Shapes and this kind of stuff are very easy to come by. So, but this is definitely one thing I've got given on an exam where I said, draw this, but I didn't, you know, write code to draw this, but I didn't give, no. I think on the exam, I gave the code and told students to draw, and then the image that got produced was this. So, you know, you can see that there's a benefit for me doing both the ways, telling you, hey, give me code that draws this as well as draw what I'm doing. So yeah, so we'll take some time on this one as well. And then I think I have one more after this one. And at least one more from this block of things. So to answer a question you might have, right? This first block, which, or at least on my page, the first block, because it scrambles them all, right? Is this one over here that says return to center with the bob.goto. Just to refresh your memory, goto moves the turtle on the XY coordinate plane to a specific location. And 0, 0 is the center of the Euclidean plane our turtle exists on. Or Cartesian plane, but which is, so 0, 0 is that starting location. Okay. You have, I've learned things on exams from students because I think sometimes a student will use like a question, you know, a function that I didn't even know existed, but they learn through grading the documentation. Happens. I mean, the issue is, again, programming languages are huge. When you're expected to know enough to teach all of them, they're generally focused on the necessities and the important things that are required for each class. Mhm. Thank you. All right, so let's go over this one. Okay, remember the turtle.hide, what it does is that it makes it so the turtle doesn't appear on the screen, so we don't have a little triangle, kind of deal over there when our picture is finished. So here what we can do is kind of exploit the fact that this is a symmetrical figure, right? It's symmetrical this way and symmetrical this way. Okay. And specifically what we see here is that we've got a for loop that runs 4 times, and we don't see any for loop anywhere else. So really what this breaks down to is that we've got this figure, and and the first part of the for loop says move forward 50 steps. And if we look at all these lines, they're all the same length: forward 50, forward 50, forward 50. So it's saying 4 times I'm going to do a bunch of codes and a bunch of things, and the start is always going to be moving forward by 50. So really what this is that we have got this, 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 and this. In other words, each of these 4 branches is one iteration of the for loop. So we import the turtle, and remember what I did on the exam on paper is I gave students this code and told you to draw what it was. For range in 4, bob.forward 50. Okay. So first thing this does is that it moves forward 50. All right. And this one says return to reset heading, return to center. And sorry, so this looks like kind of something that would go on the end or close to the end. And then this definitely goes at the very, very end over here. So what do I do? So I've moved forward. This says turn right, move forward. So if I went this way first, let's look at this block. If I turned, so I know that the first move is this. If I then say turn right 45 degrees, it would go forward and then backwards. So that's plausible. Similarly, for the next step, it says left 90 and move forward 50. So if we move forward backwards and turn left 50 and turn left 90 degrees and move forward 50 degrees, that's also plausible. So let's see. We take this code, move this over here, right? This would give me essentially, if I do this code like this in this order with the forward 50 on the for loop that's already down there, and then turn right, go forward 50, back 50, turn left 90 degrees, right? Thinking forward, I'd actually draw this entire branch, but my guy's over here now. But then I've got this handy bit that says, reset the heading and then return to center. So if I turn right 45 degrees, right? So I would have turned right 45 degrees, left 90 degrees, then right 45. So it would have got in my heading basically back to the center. Then pen up so that I'm not drawing anything anymore. Go to the center. So basically I reset back at the center. So let's see this, boom. Boom. And then this goes back to the center. And now this last one says turn for the next branch, which definitely sounds like, you know, there's something that goes at the end of this for loop block. And then here are all drawings. Yeah, definitely this is better. I find this to be better for questions on a computer and drawing them to be better for questions on paper. So definitely kind of a this kind of thing over here. But personally, I feel like something like this one, which is, sorry, this next one, this question 4, is something that's fairly fair game. Maybe a bit simpler, but the idea here is that complete the code to turn what we have. So basically I say, here is code. It is almost complete. It does stuff. You can run it. And when you run it, it does this, right? I want you to change the code. So when you run it, it instead completes the T-tetremo. Apparently I really like tetremos. That might be relevant for practicing or something, you know? By the way, if you're thinking of doing some kind of, if you're still trying to think of games to do for a project, you know, doing something like Tetris, but with a twist is always a good. I've seen basically Tetris where there was one version that I got like a year or two ago from students who they programmed the game of Tetris, but the blocks fell from each side. You had to you were catching them from the center. You had to make sure you caught them all, and your goal was to make sure you stayed from going outside the screen for as long as possible. So it was a different kind of flip on that game. But anyway, we can run this code. This is definitely something that wouldn't be necessarily on the exam, but something similar. So we run this and we see we get this. And we see in the comments, and this is the kind of thing that would be fair game, where I give you something almost complete and tell you complete it so that it does X, right? So, and then here in the comments, I'm telling you put your code below and your code above, in between these two lines, in between this space. And probably give you plenty of space to work in case your handwriting was, big. That's another thing. The amount of space I give you isn't necessarily indicative of how difficult a problem might be. It's indicative of I have to compensate for people like myself who have terrible handwriting. So, all right, so let's go ahead and work on this one where basically we need to just fill in this last missing square for the Tetratremo. Yo. All right. So now one important thing that I should mention with regards to this is that with questions where I like say complete the code, I'm not really, unless I specify something specific, like you must use a for loop or something, I'm not picky about how the job gets done. I'm really not. There are multiple ways to do this. One is just simply arranging the turtle so that it draws a single line, moving the turtle and drawing a single line. Another way is, just turning the turtle from where they are and drawing a square. There's multiple ways to do this. So again, a lot of the time for most questions, if it works, I'm happy. Okay. So, this, because again, it's a problem solving problem. Now, if I go over an exam, I might point out, okay, this is like my preferred solution because I think it's the most elegant, but like when you do interviews, whiteboard interviews for like FANG companies, Facebook, Apple, Netflix, Google, the general rule of thumb is for those interviews, doesn't matter if your answer is ugly, doesn't matter if it's inefficient, you want an answer on the board versus not having anything on the board. Get an answer on the board, refine it later. That is, and a lot of that is the way I think about just problem solving in general. Having a solution is better than having no solution or trying to perfect the perfect solution. You know, but that being said, you know, personally, just I would always refine if possible. So first thing I would do over here is, you know, I would run it a bunch of times to see how the turtle ended up, or I would just comment out the hide line to see where my turtle is. And then I would restore it at the end. So I commented out the line that says hide the turtle. Or I'll restore it at the end. So I see that basically there's a couple different ways to do this. The first thing I'm gonna have to do regardless is that I gotta turn the turtle to face north, this way. Because then I can do one of two things. I can either move the turtle this way, then turn him to the right, and then draw, and then done. Or I again face him this way, face the turtle this way, and then face the turtle to be up, and then call draw square so that he will just simply draw a square. Yes, is he going to draw more than he needs to? Whatever, doesn't matter. It works, and it's a short solution. So let's just go ahead and code one of those up. So uncommenting this because I generally don't want to make changes to that. Although, like, if you did that, probably would allow it because that's a clever kind of thing to do on an exam. Change my, you know, you didn't say you couldn't change your code, Professor Rosen. I guess not. So, so what I would do, since the turtle is facing to the east and I want him to, to the west and one face to the north, I would say Bob dot LT left turn Bob 90 degrees. And then as we can see now, or as we'll see very briefly, he'll turn, he'll finish the square and he'll turn. Oops, nope, he faced down. Left turn, right. Got my left and right confused for a second. Square, I completed kindergarten. Okay. So now he turns right, faces up, and now I can do one of two things. I can say Bob dot I can say draw square. Bob, and then 50, and that would draw the square. That would solve this in 2 lines, but might not be intuitive because again, it draws more than you actually need. Okay, the other thing we could do is that we can manually move him. Bob dot forward 50. That brings him to the top. That would bring him to this corner over here. Bob dot right turn 90, and then Bob dot forward 50. And there we go. So again, either of those kind of ways of doing it would give you full credit on this question, because again, I didn't specify. I just care about it actually getting done. Now, I also got a good question about like, why did draw square have to come first versus El Tetrimo? And the answer is, in a lot of languages, you have to define what of the functions that come first. You know, so you have to in a lot of languages like C and C++, the order in which you define things matter. You have to define things in those languages before you use them, and that's just the practice I've fallen into. Also, from a technical standpoint, there's only one possible answer for the Parsons puzzles. I have to give it a correct answer. There's not an incorrect answer. or multiple correct answers. So by specifying that this has to be done first, this makes it so that there's only one possible configuration. That's also why there's some like weird blocking and weird arrangement of blocks that I do in this code. It's so that there is there's unambiguously only one correct answer. Sometimes I miss that. Sometimes I find that there's another answer and the students will run it for me and I'm like, okay, I guess that technically works. Like I think if I'm remembering correctly, this technically works, having this over here. That technically works, even if that's not what I was intending. You know, so it's not always, so as you can see, it's not a foolproof kind of way to do things, but. All right, so for right now, I'm going to, so again, I'll send out these things. But hopefully this gives you an idea of what the exam is like. Before I dismiss you, I just want to open up Canvas to kind of look at what we're planning on doing next week. Or what I had previously planned for next week. Why does it keep wanting me to log in? I don't know. Let's see. Yeah, I should have time to do that. But let me just finish this module. Okay. So yeah, the for loop. So next week, watch the videos on the for loop that are posted. That's more information on how the for loop works. And then I think I'll be moving the stuff from module 5 into I'll be doing, well, I'll move when we do this Thursday exercise of blaming Pope Gregory the 13th. It makes sense.
Yeah, Pope Gregory,
Yeah, that guy.
that guy. 12 years Catholic once. Don't know who that is.
It is he is the one who instituted the Gregorian calendar.
Oh, that's really cool. I didn't know that actually.